All right. Hi, everybody. My name's Travis Sondrol. This is my final project, stop and control. Just want to go over the circuit to control a basic stoplight that would control traffic flow in both directions of an intersection. It's a complicated circuit. To me, when I looked at it, it looked like something that would be a good application for a flip flop. I only touch on just your basic light changes. The capability of the lab kit was such that couldn't really do too much more. There is a lot of capability here. You could add motion sensor, pressure sensors. You could mimic traffic and pedestrians and really do a lot in the ways of controlling the lights. But through this, I was able to, control the basic green, yellow, red swaps that needed to happen from state to state, and I think it turned out okay. Um, this is what the circuit looks like. You've got a north-south and an east-west, and I only showed two. Of course, there'd be one in each direction, so it would just be a mirror of this, or mimic this one. So basically, here's my flip flop, two flip flops, a bunch of AND gates, some OR gates. Utilized an OR gate for the yellow light. There's a point here where both the red and green are off, and that's when the yellow comes on. So it worked out pretty slick that way. Go to the second part. The lower portion is the countdown timer. So what I did is I figured out the function generator. My states happen every 10 seconds, so I was able to time the function generator for the countdown timer to that 10 seconds, so they match up, and it gives you an idea of when the state will change. So just kind of a cool little feature there that I thought every stoplight should have. It'd be nice to know when the light's going to change and how long you're sitting there. In the real world, on my actual circuit, we didn't have the countdown chip in our kit, so it counts up, but still got it to work. It just counts to 9 instead of to 0. It's pretty straightforward there. As far as the operation of the circuit, I do have it right here. Pull it up, show you real quick the simulation. So there's basically 4 states, and we'll see that in the next slide, but I just wanted to show you how it works. See, we count down to 0, and then we swap. Yellow light comes on for green. Now this will go red, and this will turn green. Count down again, we'll get a yellow light, and we will return to the first state right now, which is green up top, red on the bottom. So pretty straightforward. It's a pretty slick little circuit. Get rid of that. This is what the circuit looked like when we're done. I was able to purchase some stoplight modules, which worked fairly well. At first, it caused me some troubles, and I cover that in the troubleshooting. It was kind of a funny story, but lots of wires, lots of pieces and parts. I didn't have any 3-input OR gates, so I had to use a 2-input OR gate and piggyback them onto each other so I could get 3 inputs and 1 output. But other than that, it's pretty straightforward. It looks like spaghetti, but it worked well. Here's our state diagram. Every 10 seconds, you get a state change. North, south, green, east, west, red. Works through that. And then the flow diagram pretty much mirrors that, but there's a flow chart to see that. State diagram tables, flip-flop truth tables here. Expressions are algebraic expressions here. And to end troubleshooting questions, issues with the circuit, it was really complex. I had to be careful with the real estate on the breadboard as I went through to make sure I had enough room for everything. It functioned. I wanted to kind of look good, so I tried to get my wires in there so it was all right. The LEDs I purchased so it was fully functioning. We didn't have enough LEDs in the kit, so that was nice. But the LEDs were dim, and in my report, I had to turn the lights off so you could see the light. But it caused me some problems because I couldn't see the green light coming on, and I thought I had messed something up. And so once I figured out that, oh, it's just really dim and I turned the lights off, then I could see that it worked. But it caused me some unnecessary troubleshooting, really. And then I used multilism so I could test the circuit and make sure it operated per the design before I constructed it, and that really helped. So, hope you guys like it. If you have any questions, email me, Travis Sondrol, ndus.edu, and this will be posted to YouTube. Thank you.